In this video, we're going to talk about exponential growth and decay functions. First, the vocabulary. An exponential function is a function in the form f of x equals a times b to the x, where a is the initial value and b is the rate of increase or decrease. Exponential growth function is a function in the form f of x equals a times b to the x, where a is the initial value and b is the rate of increase, and b is greater than 0, and a is greater than 0. So a is always going to be greater than 0. Well, not always, but for the most part. An exponential decay function is a function in the form a times b to the x, where a is the initial value and b is the rate of increase, where a is greater than 0 and b is less than 0. And an asymptote is a line that the graph y equals f of x approaches the variable as the variable x approaches a very fixed value as x increases or decreases without bound. A condominium complex charges $185 per month for the homeowners association fee. The rates can rise every year because of inflation, but they promise not to raise the rates more than 10% each year. Keep in mind, though, that if they raise the rate by 10% the first year, the second year is now more expensive. If they raise the maximum again, they are increasing the original 185 plus the first year's adjustment by 10%. Fill in the table for the situation for 10 years. How much could the homeowner's fee be in 10 years? Use the function f of t equals 185 times 1.1 to the t, where f is the fee after 10 years. So let's start filling our table. So we have 0, year 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So now we're going to fill in our f of t. That's the fee for every 10 years, or every year. So 185 parentheses 1.1 raised to a 0, and we get 185. So this is our initial value. That makes sense. That's this year. So now we're going to plug in 1. So after 1 year, we're up to 203.50. Do the same thing, plug in 2. We're up to $223.85, $223.85. Raised to a 3, 246.24. Raise it to a 4, 270.86. Raise it to a 5, 297.94. Raise it to 6, 327.74. Raise it to 7, 360.51. 8th year, 396.56. raise it to 9, 436.22, and then in the 10th year, we're at 479.84. So the homeowner's fee will be $479.84 in 10 years. Homeowners fee is $479.84 per year per month in 10 years. And we are done. Example 2. The town of Centerburg is suffering from a decline in population. A demographer has predicted that under current conditions, the current population of 28,500 will decrease by 2% each year over the next decade. However, a manufacturer claims that a new factory will reverse the trend and cause the population to grow by 4% annually. Create equations to describe the population of Centerburg as a function of time used under these two conditions. Function f, the population of 28,500 increases by 4% each year with a new factory. So let's write that function. F of t equals our initial value is 28,500, and we're increasing. So to write our function, we want to do 1 plus our percentage of decimals. So we're going to take 4 divided by 100, which gives me 0.04. This will be 1 point plus 0.04 raised to a t. So that gives me 28,500 times 1.04 raised to a t. And for function g, the population of 28,500 decreases by 2,000 each year with no new factory. So we'd have g of t equals 28,500. And then since we're decreasing, we're going to do 1 minus, we're going to do 0.2% of the decimals. We're going to do 2 divide 100 to get 0.02. So 1 minus 0.02, since we're decreasing, raised to a t, is going to give me 28,500. 1 minus 0.02 will be 0.098 raised to a t. Now, compare the projected population after 10 years. So what we're going to do first is we're going to find f of 10, which is just going to be 28,500 times 1.04 to the 10. And that gives me 42,187 approximately. And then we're going to find g of 10, which will be 28,500 times 0.98. And we're also going to approximate what that is because we can't have decimals of people. And that gives me 23,287. We'll subtract the two answers to get the difference. So when we subtract them, there's a difference of 18,900 people. 18,900 people. So this shows you how what the compare how to compare the projection of if the population was increases versus decrease. Example 3. $2,500 invested in an account with a 5.3% annual yield. What is the annual growth factor? So first we have to do 5.3 divide 100. And since we're growing, we want to add. So first 5.3 divided by 100 will be 0.053. So to get the growth factor, just do 1 plus 0.053, and that gives me a growth factor of 1.053. So what is the equation for the balance after 10 years? So we have A of t equals 2,500 times 1.053 raised to a t. Now we want the balance after 10 years, or 7 years. So that'll be just A of 7 equals 2,500, parentheses 1.053 raised to a 7. And from here, we're going to use a calculator. So it'll be 2,500, parentheses 1.053 raised to a 7. And we get 3,588.71. So $3,588.71. What value is associated with t equals -2? So here we're going to plug in -2. So 2,500 parentheses 1.053 raised to -2, and that gives me 2254.67. What does this mean? How much money you had 2 years ago. And we are done. Example 4. For each function, determine the domain and range, the y-intercept and x-intercept, the asymptote, and whether the function is a growth or decay function. So first, the domain and range. For the first function, we'll just write it. D is all real numbers, or you can just write from -infinity to +infinity. The same thing for the other function. Domain is going to be from -infinity to +infinity. As we can see, this never stops going on. Our range. It doesn't appear to get, the buff function doesn't appear to go below 0. So we'll say from 0, it doesn't equal 0, it looks like it's approaching 0, to +infinity. And on the right function, it looks like I'm approaching, looks like -1, -1 to infinity. And I'll dot in my asymptote. Okay, B, the y-intercept and the x-intercept. So B, the y-intercept, for the first graph looks like it's at approximately 0, 1. X-intercepts, I don't see any because it doesn't cross the x-axis. So we'll just say there's none. For B, for the right one, the y-intercept looks like it's going to be at 0, comma 3. And the x-intercept looks like it's at 2, 0. For C, the asymptote. So the asymptote is the same as the range, so I just thought that in previously. So the asymptote you're going to say is y equals 0 for the left one, and for the right one, looks like it's approaching negative 1. So you just say y equals negative 1. You can see that using that line that I am drawing in. And D. If it's going up from left to right, it's exponential growth. So the first graph is an example of exponential growth because it goes up from left to right, and the right graph is going down from left to right, so that's exponential decay. Growth, and the right graph is exponential decay, and we are